episode on Wisdom Mathematics tutorial on complex numbers, conversion from one form to another, the second part. Now, in the previous video we have done, we looked at how we can convert complex number from one form to another, and we were able to convert complex number from rectangular form to polar form and Euler form. Now, rectangular form, as we know, is a plus ib, while polar form is r bracket cos theta plus I sin theta, and Euler form, which is exponential form also, is r exponential I theta. So in the previous video, we converted complex number in rectangular form to polar form and also to Euler form. Now, in this video, we are trying to see how we can convert a complex number from polar form back to rectangular form, or from Euler form back to rectangular form, because this rectangular form is regarded as the general form of a complex number. Now, in the question, we say convert the complex numbers I z equal to 5 brackets cos 30 plus I sin 30 and z equal to 3 exponential 60I to rectangular form. This first one, if you compare it with this, you will see that this complex number is in polar form. Polar form. So this particular one is in polar form, while this one is in Euler or exponential form. So we are going to convert this polar form to rectangular form. This is rectangular form. And secondly, we are going to convert this from Euler form to rectangular form. In the first one, we have that z is equal to 5 cos 30 plus I sin 30. Now, for us to convert to rectangular form, we have that our rectangular form is z equal to a plus ib. Then, comparing rectangular form to polar form, we have that a is equal to r cos theta and b is equal to r sin theta. Theta there is the argument here, this 30. While the r is this modulus. The number here is modulus, while this one here, which is the same as this, is the argument. So in this particular question now, the modulus r is 5 and the argument is 30. So we have that modulus is 5 and the argument is 30 degrees. So we're now going to get our a using this formula and our b using this formula. When we get a and b, we're going to substitute into this equation 1. We're going to have our answer in rectangular form. Now, since we have our r as 5 and theta as 30, we have that a is r cos theta, which is 5 cos 30, to give us 5 cos 30 will give us 4.330 and so on. So you can see that a is approximately 4.3. Then for our b is r sin theta, which is 5 sin 30, to give us 5 sin 30 is 2.5. Now, since we have that our a is 4.3 and our b is 2.5, our answer, which is complex number in rectangular form, since it is a plus ib, it is now going to be a is 4.3 plus I, b is 2.5, So we can say that our z is equal to 4.3 plus 2.5i. So this I can be in front, it can also be at the back. So this is the solution to the first question. Now, what we have done is just to get our a and our b, we substitute into the general form, which is this of a complex number, which is our rectangular form. So we substitute for a and for b, that will be our answer. Now, in the second question, we have that our complex number there is z equal to 3 exponential 60i. So our theta, which is our argument, is 60 and our modulus is 3. Why is this like this? It is so because in normal Euler form, we have that z is equal to r exponential I theta. So the number we see here before the exponential is the modulus, that's our r. So if you compare this with this, you see that r is equal to 3. Then if you compare this to this, you see that, look at I and look at I. So this 60 here stands for the argument. So since we have known this, and our rectangular form is a plus ib, we can now get our a, that our a, this a here, which is the real part, and this imaginary part, can be obtained using the theta and the modulus. Now to do that, we have that a is equal to r cos theta, which is that a is equal to 3 cos 60, which is 1.5. Now this is our a. Then for the b, we have that b is equal to r sine theta. So we're going to have 3 sine 60, and this is going to give us 3 sine 60 is 2.598 and so on. So b approximately will be 2.6. So since we have gotten the values of a as 1.5 and b as 2.6, we now substitute into this rectangular form to have that our value will now be z equal to 1.5 plus 2.6i. That is the complex number in rectangular form. Please try to subscribe to our channel, Wisdom Mathematics, on YouTube. If you click on search, you type Wisdom Mathematics, you will be directed to YouTube where this our video and other videos are. Then you can click subscribe so that you have our subsequent videos on mathematics. See you in the next class.